Okay. So this is the solution of the damped vibration. Okay, and we have already solved the. We have already find out the case 1, that is for the heavy damping. Okay. Now case 2. Critical damping. Critical damping. If K tends to omega naught. If K tends to omega naught. The equation of equation 5, right? What is the equation? 6. 5. After the 6. So if K tends to omega naught, then equation 5 becomes x equals to e to the power minus kt into a e to the power beta t plus b e to the power minus beta t, where beta equals to root over a square minus omega naught square, where beta equals to root over a square minus omega naught square is a very small quantity. Why it is very small quantity? Because the K tends to omega naught. That means the difference between K and omega naught is very small. Tends to. So why it is K square minus omega naught square, then root over. So it is again very small. So if it is very small, beta is very small, then what is the expansion of E? E to the power x, if x is very small. Anyone? E to the power x equals to? বলো না কিছু একটা বলো 1 তারপরে কি হয় 1 plus x square by factorial 2 like this বলছি তো বলতে কি মেরে ফেলবো না okay so 1 plus x square by factorial 2. Now if we neglect the higher term, x is very small, so if we neglect the higher term, then what's happened? Therefore, as beta is very small, therefore x equals to e to the power minus kt into a into 1 plus x. X means beta t. Here x is the beta into t, so 1 plus beta t. Similarly, plus b into 1 minus beta t for this one. So this equals to, or x equals to e to the power minus kb into a plus b plus a minus b into beta t. Or x equals to e to the power minus kt into a plus b is another constant. We take it as p and plus a minus b equals to q into beta T or Q into T. Q into T. Because beta is also a constant. Q into T. X equals to e to the power minus kt into P plus Qt. Where P equals to A plus B, where T equals to A plus B and Q equals to A minus B. Two constant again. And equation 7 is the solution for critical damping. Equation 7 is the solution for critical damping. Okay? Critical damping. Beta is constant. Beta is root over k square and omega naught square, which is also a constant. The beta is constant. B equals to A minus B into beta. E equals to A minus B into beta. Sorry. A minus B into beta. Thank you. Okay? A minus B into beta. Okay. This type of motion is known as critically damped motion. This type of motion is known as critically damped motion. Critically damped motion. In this case, damped oscillatory motion. In this case, the damped oscillatory motion suddenly changes into a dead beat motion. Into a dead beat. Okay, so become DEAD, BEAD. Dead beat motion. The decay of X means displacement. The decay of X is more rapid than the overdamped motion. Okay, so what's happened? Here the decay is more rapid. Okay, more rapid than the overdamped motion. Full stop. This is also non-oscillatory motion. This is also non-oscillatory motion. This is also non-oscillatory. This is also non-oscillatory motion. Okay, non-oscillatory means where there is no oscillation. So here also there is no oscillation. It is decay exponentially. Okay, so can you give the decay of X is more rapid than the overdamped motion. So if we plot the graph like this, then this is for for the critically damped motion. Critically damped motion. Okay, and this is for the over damped motion. Over damped motion. Okay, so it is also given, maybe given in the exam. So graphically, the decay of displacement with time for critically damped motion and over damped motion. Okay, then you have to draw this graph. So you can see that here the critically damped motion is more rapidly decaying than the over damped motion. Okay, that is the common graphical representation. Now case 3. Case 3. Light damping. Light damping. Or under damped motion. Light damping or under damped. Under damped motion. Under damped motion. Where is it? Now the light damping. What do you mean by light damping? If K less than omega naught. Okay. If the damping force is less than the angular frequency or natural frequency, then that is called the light damping. Okay. When K less than omega naught. When K less than omega naught. Then what's happened of root over k square minus omega naught square? K omega থেকে ছোট হয়ে যাবে তখন root over ভেতরে কি হবে মাইনাস হয়ে যাচ্ছে তাই না তাহলে আমরা সেটা কি করব I root over minus 1 means I ঠিক আছে when this one when k less than omega 0 then root over k square minus omega naught square equals to I root over omega naught square minus k square. Right? When I is equal to root over minus 1 complex quantity. So this is equals to, which say I into omega for simplicity. I omega. Omega equals to root over omega naught square minus k square, where omega equals to root over omega naught square minus k square. বারবার একটা তো বড় না লিখে আমরা কি করব লিখে যাই ওমেগা I omega. Then equation 5 becomes x equals to e to the power minus kt into a e to the power এটা কি হবে I omega t, তাই তো this one is omega or I omega t plus b e to the power minus I omega t. e to the power I theta cos theta plus I sin theta. Good. So this is equals to e to the power minus kt into a into cos theta plus cos omega t plus I sin omega t. Similarly, plus t into cos omega t minus I sin omega t. Any problem up to this one? Still now, you are not joining the canvas, join the canvas and follow what you do. You join code with them. Join code with them. Yeah, join code. You join for account 19 बाकी है जो. हमें किंतु assignment hard copy दे बोला. You have to complete the assignment in the canvas only. बोला तो any problem? नहीं. So this is equals to e to the power minus kt. देखो फॉर्म में डोंट टॉप. So this is cos omega t. This is also cos omega t. Okay? तो ये क्या होगा a plus b cos omega t plus a minus b into I sin omega t. A minus b I sin omega t. A minus b I sin omega t. So you can see that again a plus b and a minus b into I is also a constant. Okay. Now we put a plus b equals to c sin phi and a minus b into I equals to c cos phi, another constant. C and phi are also constant. So put it in equation 8. So from equation 8 we get x equals to e to the power minus kt into c sin phi cos omega t plus c cos phi sin omega t. देखिए फॉर्मूला बोलो sin omega t plus phi और x equals to c का बाइडिविजर्स में c e to the power minus kt sin omega t plus phi. Equation number 9. Okay, so what you will see from the equation of 9, bolo what you can conclude. What is the conclusion from equation 9? What is c e to the power minus kt? And there is a sign term. In the right hand side, c e to the power minus kt sin omega t plus phi. That means x is oscillating as oscillation. C e to the power minus kt is the amplitude of oscillation. So amplitude is not constant. It is not C only. C e to the power minus kt. That means as the time passes, the amplitude decreases, but there must be some oscillation. So as the time passes, oscillation decreases with exponentially. But there is the oscillation due to the sine term. Okay, so this is the damped oscillatory motion. Case 1 and case 2 is non-oscillatory motion. There is no oscillation, but here is some oscillation. But after some time, the oscillation decreases and the amplitude decreases and the oscillation stops. That is the known as the damped oscillatory motion or light damping. Okay, so light damping is only for the light damping we get the oscillatory motion. This represent a damped oscillatory motion. This represent a damped oscillatory motion of frequency f. Of frequency f, small f, where f equals to, what is the frequency? F omega by 2 pi. Good. Where f equals to omega by 2 pi. And what is omega? Omega is 0. Root over omega naught square minus a square by 2 pi. Okay. So this is equals to omega naught by 2 pi root over 1 minus a square by omega naught square. If you take the omega naught square common, or f equals to, this is called f naught, omega naught by 2 pi, f naught root over 1 minus a square by omega naught square. So this is the frequency of vibration of the damped oscillatory motion. This is the frequency of vibration of the damped oscillatory motion. This is the frequency of the damped oscillatory motion, and the amplitude is A equals to C e to the power minus kt. So this is the amplitude of the vibration. In simple harmonic motion x equals to only a sin omega t plus phi, but here it is c e to the power minus kt. Okay, as a equals to c e to the power minus kt, so the amplitude of vibration decreases exponentially as the time passes. So for the sine term we get the sine curve, and for the a e to the power minus kt we get the amplitude amplitude decreases exponentially. Okay, so you can see that the amplitude decreases. Okay, so this is the damped oscillatory motion. E to the power minus kt is called damping factor. E to the power minus kt is called damping factor. Okay, so this is the damped vibration. Now we go for the attenuation coefficient. আজকে একটুই থাকে কারণ এটা আরম্ভগুলো শেষ হওয়ার কাছে। So today, after this one, the next class will discuss the attenuation coefficient of the damped vibration. In the attenuation coefficient, there are three terms. One is logarithmic decrement, relaxation time, and quality factor. We will discuss it.